In classical experiments, there are three components. Now, I know there are four things listed there, but I'll explain it when we get to that point. So the first set of components is an independent and dependent variable. An experiment examines the effect of an independent on a dependent variable. The independent variable is typically the stimulus, and the stimulus is applied, and the outcome or the effect of that stimulus is measured. The independent and dependent variables appropriate for experimentation are nearly limitless. To be used in experimentation, the independent and dependent variables must be operationally defined, usually before the experiment begins. We're accustomed in this class to talking about operational definitions, so things have to be very clearly stated. This is how this is going to run. This is what we are going to do. This is how we are going to interpret the outcome. These are what we expect to see, and this is how we're going to measure it. Like other quantitative methods, experiments require specific and standardized measures and specific and standardized observations. For example, we could study the impact of TV violence on children by taking a group of children and watching them play together. Then we have the children watch a violent television show or a violent movie. After that, we can observe the children's play behavior following the film to see if they engage in more violent or aggressive play after that. We would probably also monitor a group of children who didn't watch the violent show and measure their behavior at both of those times as well. Here, the independent variable then is exposure to violence on television or in film, and the dependent variable is aggressive behavior in children. So here we have a chart or a flow chart that shows that. So we measure the dependent variable, aggressiveness and behavior, in the experimental group and in the control group. We expect these two groups to be the same before the study starts. So these children aren't different. They're not different ages. They're not different genders. They go through a whole battery of psychological tests that, we don't have one group that has children that are prone to aggressive behavior and one that doesn't. These are the same. The children are anticipated to be the same at the beginning of the experiment. One group, the experimental group, is administered an external stimuli, which is the film, and then they are remeasured, both groups, on the dependent variable again. So again, we're measuring aggressive behavior in play. So this is your classical experimental style. In the simplest experimental design, this is what we see on the screen. Subjects are measured in terms of a dependent variable. They're exposed to the stimulus, and then they're remeasured in terms of the dependent variable. So any differences between the first and the second measurement are then attributed to the independent variable. This is what we call pre-testing and post-testing. So pre-test, measurement before, post-test, measurement after. We test the subjects prior to the experiment to see where they are initially. Then we perform the experiment and retest them to see if they've changed in some way because of the experiment or the application of the independent variable. One of the problems that we have with a pre-test, post-test design, though, is that people may respond differently the second time because they've seen the test before. For example, if I handed out a survey in class asking you how you felt about experiments before I covered chapter 8, and then I gave out the same survey after I finished the chapter, you might respond differently, not because you changed your mind because of what I covered, but because you had seen the questionnaire before. This is even more likely the case in other types of studies. For example, if I give you a survey asking about dating violence that includes a series of scenarios with different levels of physical and sexual violence, like pushing, slapping, punching, etc., and then I ask you to read scenarios and rate each one in terms of acceptability of the situation, after you fill out the survey, then I show you, so I ask you to read these scenarios as part of it. And then after you fill out the survey, I show you a film that contains a great deal of sexual violence. And after the film, I give you the same survey. What do you think I'm testing? You, having filled out the survey with the same scenarios, affect your answer the second time. I'm testing whether watching violent sexual materials affects the acceptability of physical and sexual violence. You probably clean up your answers the second time, making it look like the film had no effect or the opposite effect I would have expected. Even more problematic for experience is that the very act of studying something may change it. We often say and do what we think others want us to say or do if they're watching us. And we'll talk more about that later when we talk about the Hawthorne effect, which is that fourth element down there at the bottom of the list. So the double-blind experiment allows us a little bit more control, and we see this often in medical research. Neither the patients nor the doctors who are distributing medications in like pharmaceutical studies know which patients are getting um, the experimental drug or the placebo, right? So the placebo is a drug that doesn't do anything. And they do that because there is an understanding that if the doctors know who's getting what, they're going to treat the patients differently. And those different treatments of the patients, even just the approaches or the level of empathy or what have you that the doctors will show towards the patients will reveal something that will affect the patient's behaviors. So even the doctors don't know whether what they're distributing to their patients in these pharmaceutical studies, whether it is the actual medication that they're testing or whether it is a placebo or an empty pill, right, that doesn't have anything in it or doesn't have anything that would have any effect. Researchers using experiments face the same issues regarding sampling and subject selection as researchers doing other types of social research. Since most research takes place at universities, very often subjects are students, and typically an experimenter will advertise in the college newspaper or in classrooms for participants in social experiments. Students are often also compensated for participating in some way. Obviously, having students who volunteer and who are compensated for their participation has an impact on the reliability and the generalizability of results. Undergraduate students, as we've talked about, are not typical of the public at large. In general, since we use experiments for explanatory research rather than descriptive research, it is more acceptable to make conclusions based on this rather special population. In addition, the use of control groups also increases the generalizability of results. Ideally, the control group and the experimental group are the same, as we said. So how do we ensure this? One way we do this is through probability sampling. Probability sampling is rarely used in experiments because, as we discussed, it's based on the idea of large samples that are taken over and over in the long run. So we can't actually be sure that we're grabbing a good representative sample because we don't have all the information that we need. But randomization is a common tool that's used when selecting subjects. After recruiting the subjects, researchers will randomly assign participants to the experimental group and the control group. And while we can't assume that they are exactly alike, we can assume that they're reasonably similar to each other because they were randomly assigned. And again, large numbers of subjects are best with randomization. It can be difficult if you have small samples to, even if you're randomly assigning them, not to get some sort of a weird sample out of it. Sometimes experimenters also use matching, and this is similar to the quota sampling that we talked about earlier in the semester. They create matched pairs of subjects with one in the control group and one in the experimental group based on the characteristics that they think are most important in the study. For example, if our recruits included 10 Hispanic men in their early 20s, we could place half in the control group and half in the experimental group if we believed that age and ethnicity were important factors in the study. I worked on a research project that, while not a true experiment, used the matching system while I was in graduate school. We wanted to know if being part of a program we'd established improved student retention rates, meaning they were less likely to drop out. So we matched each of our participants with someone who had the same high school GPA, race, sex, SAT score, and so on. And then we tracked a student participating in the program with their matched student who did participate in the program to see how they fared in college. Whenever we are addressing these issues, we have a couple of things that we need to take into account. What are the pros and cons of using things like randomization and matching? Most of the statistics used to analyze the results of experiments assume randomization. So if you use another way other than randomization, your statistical outcomes may be less meaningful. You may not be in the position to know in advance which variables will be relevant for matching and which will not. So matching can be problematic that way. Randomization only makes sense if you have a fairly large pool of subjects. Remember, we said bigger numbers are better with randomization. And some researchers combine randomization with matching, creating a modified form of stratified sampling based on certain predetermined variables of interest. So they group people within these quotas. We want to get a certain percentage that look like this or that in the experimental group and in the control group, but they randomly assign them once those categorizations have been identified. Often, conducting a true experiment is impossible or is unethical. However, we can still use the principles of experimental design in what are often called quasi-experiments. In quasi-experiments, the subjects are not randomly assigned. So maybe it is too expensive to randomly assign people to treatment or comparison groups, or maybe it's unethical to do so. For example, if you want to know the effects of being laid off from a job on mental health, you can't randomly assign some people to be laid off and others to keep their jobs. That's unethical. You can't do this by matching either groups or matching by individual. You can do it by matching by groups or matching by individuals. So you can find an individual who was not laid off that is similar, and then find one who has been laid off, and those are your matched pairs, and you haven't applied a stimulus to someone like laying them off to see how it affects them. So matching groups means to select a comparison group that's similar to the treatment group. That means you find subjects to the comparison group who are similar to each individual member of the treatment group. Another example, imagine we wanted to study the effect of a new bicycle helmet in a particular city, in Macomb. Does the new law reduce bicycling injuries? To conduct our experiment, we might choose another city that's just like our city in all of the relevant aspects: the number of cyclists, the number of cycling injuries, the size, the traffic patterns, weather. And so maybe we would choose a matching city, right? And then before the new law takes effect, we would compare them on these important aspects. And then after the law goes into effect, and that's the treatment or the experiment, the applied stimulus, then we could come back later and observe the city's differing rates of injuries and to see if there's a treatment effect. If having a helmet law, 2 years out made injuries lower in the city where that law had been implemented than in the matching city that we had chosen that were similar and all these other characteristics except for the implementation of the law. There are several different quasi-experimental designs. One is called the one-shot case study, and that's where a single group of subjects is measured on a dependent variable following the administration of some experimental stimulus. There's no control group here, no pre-test and post-test, just a single group of subjects measured on the dependent variable following a stimulus. There is a static group comparison where you have an experimental and a control group, but there's no pre-test at the beginning. So one group gets the stimulus and is measured afterwards. The other group doesn't get the stimulus and is measured afterwards, and any differences are assumed to be because of the treatment. Non-equivalent control group designs is another model, and in this type, the treatment and the comparison group are not selected randomly, but every attempt is made to make them as similar as possible in all of the relevant aspects. In quasi-experimental designs, we have sometimes a one-group pre-test, post-test, or a before and after design. And that adds a pre-test to the one-shot case study, but lacks a control group. And I know that I'm using a lot of sort of jargon words and a lot of labels here, but I think that the illustrations provide a nice example. In this design, there isn't a comparison group, but subjects are compared to themselves before and after they get the treatment. So in that one group pre-test, post-test. So here is a chart, I think, that does a nice job of illustrating the differences between the one-shot case study, the one group pre-test, post-test, and the static group comparison for the quasi-experimental designs. So we have a man who exercises, is observed to be in shape. He doesn't have this observation at time 1. He exercises, and then this is him at the end. So time 2 is the implementation of the stimulus where the exercise takes place. And a one group pre-test post-test would be to take a person who then exercises and observes what happens to them afterwards. The static group comparison, you have the man who exercises is observed to be trim, whereas one who doesn't exercise, who is only tested at the end of it, only used comparison at the end of the study.